velocity, average velocity. Well, it's a speeding up puck. It's getting faster and faster and faster. And so at the very end of its descent, we want to know what the speed is. So that's going to be the final velocity. Now, looking at this information, it looks like we don't have enough of it. We don't have enough information to solve the problem. And that's not exactly true when you understand the context clues or the secret encoded message of these kinds of word problems. When you see words like drops or releases, that implies that the motion of this object was 0 at the very beginning. So somebody drops this chip to win a prize. They're not throwing it, they're not, flinging it, they're just dropping it. And so we can actually go back to the given information and say the initial velocity is 0. Okay, so with that in place, we are able to look for an equation now that can piece everything together. We're looking for a final velocity. We have an initial velocity and a displacement and an acceleration. So I see two equations that have displacement in it, but we don't have a time for the descent of the puck. So let's use this equation. We're looking for the final velocity and we have everything else. So we'll use this final velocity squared equation. Now typically I will try to solve an equation for what we're looking for. This one is squared. So I would really need to take the square root of this in order to solve for it. I'm going to save that until the end. I don't want to forget about it. That would be a mistake, but I want to save it until the end just because I think it makes it a little bit more neat. Whenever you're taking the square root of both sides, you have to put in the plus or minus, and I want to save that till the end. So it's already rearranged for us to have the final velocity by itself. So let's just substitute in some numbers and solve our problem. So the initial velocity we said was 0. The acceleration is -5.8 meters per second squared, and the displacement is -2 meters. And now we solve. And as we solve, I forgot my vector symbol up there. It's going to be all this together multiplied is 23.2. And that's going to be meters squared over seconds squared. And now we're ready to take the square root of both sides. So when we do that, it undoes the square. So we have final velocity equals, and whenever you take the square root of both sides, you have to do a plus, minus, you have to do positive or negative, and then this is 4.8 meters per second. In physics, you're not okay to just leave it like this, because in physics you're not just doing a math problem, you're actually interpreting reality and you're trying to understand what's going on. So you need to pick the right direction. Which way is the puck moving, just from the context of the situation. So it's moving down the slope. So according to the way we've defined our directions in this problem, since it's moving downward, it's going to be negative. So our final velocity of this puck is -4.8 meters per second. So there we have it. That's all I've got for you in this video. Remember, everything you have is a gift.